My name is Shane Johnson. I am responsible for product marketing here at Snorkel. And I'm also happy to say that we're joined by Colin here from Amazon, but I'm going to turn it over to you, Colin. You want to say hi and introduce everyone?
Hi, gang. I'm Colin Poole. I work in our startup segment at AWS, focused on helping businesses build with AI and ML. I'm super excited to be here today with the Snorkel team and to talk a little bit about our products and how they complement the Snorkel offering. It's great to be.
Awesome. Thank you. And then finally, I can see I didn't change the name here on the end, so I'm sorry about that, Chris. But we have Chris
Also
Bourne from our
Shane.
machine learning solution engineering team joining us as well.
No, hi, thanks, Shane. So my name's Chris. I'm on the solutions team here at Snorkel. Today I'll be giving, a demonstration of some of the Snorkel capabilities around fine-tuning and how we work with, Colin's team at Amazon.
Quick agenda, right? I'm going to spend my time talking about fine-tuning, kind of what, where, why, how. Then I'm kind of pivot to curating training data, right? So we can't get very far fine-tuning our models without having some very good training data to do so. But of course, that's kind of where we end and where Amazon begins, right? And then Colin's going to help us better understand the AWS AI ecosystem with some mention of Bedrock and SageMaker. And as Chris just mentioned, we'll get a nice demo at the end. What and where. These early slides are intended to provide a little bit of context. And the way I think about it is it's not very difficult to set up an out-of-the-box RAG pipeline, right? You have, some very well-known orchestration frameworks, whether your favorite is LangChain or Llama Index or any of the others that are out there. Plenty of options for vector stores. Most likely, even if you're using a relational or document database, they support vector search as well. Lots of embedding models to choose from, which we'll cover in a minute, and the same is true for generative models. At this stage, whether you're staying it up on your laptop or in a dev environment, it probably makes for a great demo or POC, especially in a controlled environment. But typically, there's a kind of a gap between this initial standing up my pipeline to something I can run in production at scale. And that's where Snorkel comes in. And so you're kind of looking to begin optimizing different parts of this RAG pipeline. I'm going to touch on evaluation today. We're not going to spend much time on prompt engineering and chunking, but we do have recordings of past RAG webinars where we do dive deeper into things like chunking and indexing and how those improve retrieval. But the real focus for today, which will be kind of joined with AWS at the hip on this one, is how do we go about fine-tuning the embedding model to get better retrieval? And how do we go about fine-tuning our generative model or our foundation model for better generation, right? Better responses. So that's kind of the area that we're going to focus on for the next hour. And then I also wanted to kind of touch on, kind of a simple reference architecture here, bringing these two worlds together. Let's kind of start on the left here. Generally, what happens is we have folks with S3 buckets and amazingly large amounts of unstructured data. I once spoke with someone who had hundreds of thousands, potentially millions of documents that they wanted to bring into their AI systems, right? Just massive amounts of unstructured data. So that process begins by ingesting that into Snorkel Flow, where a couple of things happen. One of those is that we parse those documents and we chunk them very intelligently, not just simply by the number of tokens, but based on the structure of the document, right? We're trying to keep related data together. We also have information extraction capabilities, so we can add metadata or keywords to those chunks. So if you're kind of actively involved in vector search, you will be aware that not only can you do similarity search based on embeddings, but you can do a hybrid similarity keyword search. We can sometimes be more efficient and faster if you understand what you're looking for. The second part of that is based on all of those chunks, we can also take advantage of foundation models to generate synthetic prompts, right? So once we have those paragraphs and those pages, we can send those to a foundation model and have it suggest some questions which would be answered by those chunks. So we can begin generating synthetic data. Of course, there's options for SMEs to manually add, kind of prompt context pairs as well. but that's where you're at. You're starting to kind of build this library of prompt context pairs, right? And I'll go into more detail on this in a minute. And we can feed those into our vector database. Now with Amazon, you have a lot of options. OpenSearch, Aurora, RDS, Postgres. I think you can kind of pick, whatever your favorite is, you have an option there. And then where Bedrock and SageMaker come into play, at least particularly in this context with Snorkel Flow, is that's an environment where we can send our training data and then build those specialized embedding models and foundation models, right? And even build RAG systems on top of them. And then the final piece, you might see that loop coming back, is that Snorkel Flow can also take advantage of, foundation models, whether fine-tuned or not, for a number of different tasks, right? We can ask them to generate synthetic prompts, as I mentioned, based on chunks. If we have existing prompts in context, we can ask them to generate responses or even rank responses using LLM as a judge. So it's a little bit of a circular system there, right? We want to ingest all this unstructured data, parse it, tag it, feed it to a vector database, build training data, send it over to Bedrock or SageMaker to kind of build those models. And then we can actually use those models kind of to feed back into the system for further improvement. I'll touch on those, and Colin can provide a lot more clarity on Bedrock and SageMaker here in a little bit. So the embedding model, maybe the most important part, maybe even the most critical part, I think, is a first step of improving your retrieval is to really take a look at the embedding model. Whether or not the context coming back is good or bad, right, relevant or irrelevant, largely depends on that embedding model, right? It's going to be generating scores, and if it generates those scores wrong, you can't answer your questions properly. Then you get hallucinations or kind of other undesirable side effects in your responses. The idea in the visuals here will help is that when we fine-tune our embedding models, it's almost a way to kind of move related chunks together and unrelated chunks farther apart. And sometimes there's some nuances there where it's not easy to understand whether two things are relevant or not. And if it's not easy for you, then it's definitely not easy for the embedding model. So we'll take a look in a minute at some visuals that will explain this a little bit further. But the big why is getting the right context returned for any given prompt or question. In terms of how, the way we discuss it with our customers is evaluate a handful of embedding models and see how they perform out of the box for you, right? We know they're going to need some improvement, but depending on the type of task that you're trying to perform, there's a handful of models. We tend to see BGE a lot, but I want to call out that we're seeing embedding models from lots of other places now too. NVIDIA and Salesforce have released pretty high performing embedding models. So take a look at those benchmarks, find some, start doing some initial evaluations, pick one, and then take that next step of fine-tuning it. Now, in terms of the role the embedding model plays and why we're trying to fine-tune it, here's an example in finance. With, say a pre-trained model, right, out of the box, the embedding space is the universe, essentially, right? These models are assuming that there's going to be health and finance and entertainment and media and sports and history. And so the denser it gets, the harder it is to separate things that in your world can be very different, right? So from the perspective of a pre-trained model, anything financial should be close to each other. But if you're working for a bank, you're thinking, no, that's not true at all. Investments are very different from savings, right? And even different types of investments and loans, and right, there's all these different areas of banking. You don't want them all mushed up together so that if someone asks a question like, what is the impact of the interest rate on my mortgage payment? If those things are all clustered together, they might get back chunks from Roth RA documents, right? FAQs on savings accounts. Those are not going to help answer the question. If we fine tune the model, we create that separation. And so I like these images because on the left, you have something out of the box where the orange is what we don't want, right? We don't need that attached to our prompt. The blue is what we do want. Well, what happens is typically you use that blue line to pull everything in, and it's going to pull a whole lot of orange with it, right? So you're getting a lot of noisy, irrelevant context that's being pulled in. On the right side, with the proper fine tuning, we create a much bigger separation. And so when we're picking a number, let's say 0.7 or higher on the right, you're getting virtually no bad context, right? You're almost guaranteed to only get relevant context in that one. Versus depending on the left, if we were at 0.5, 0.6, maybe something between 0.6 and 0.7, we're pulling in, irrelevant context. So we're trying to clean that up a little bit. And this is just another way to look at it, kind of a different experiment. Where on the left, you can see that they're really, really bunched together. And I would normally say that if we were at a 0.75, that's pretty high, but it's still bringing in an incredible amount of irrelevant context. And again, on the right, match it with 0.75, and it's completely clean, right? You're getting the best context available to you. So this is kind of the why we have an emphasis on fine-tuning our embedding models, because the best foundation models aren't going to generate the right answers if they're not given the right information to build them off of. And then we get to the foundation models themselves, right? So we've done some work to ensure that we're getting the right context added to our prompts. Why take the extra effort to fine-tune the foundation models as well? There's three things here. The first one I think is probably fairly broad, right? We're always trying to increase our accuracy. Foundation models are amazing in a general sense, incredibly powerful. They are not always amazing for a specific domain or even a specific business within a specific domain, right? They just don't have the information or knowledge to be effective at that level of granularity. The second ones are a little bit more interesting to me personally. The second one, around compliance, the way I think of this is I want the retrieval aspect to provide the right context in terms of providing it the information needed to answer a question, but the compliance is how it answers the question. So when we touch on evaluation, we'll see this a little bit later. An answer can be 100% correct, but also 100% rejected by SMEs, right? If you answer correctly, but it's rude, it is, curt, it is leaking, private or sensitive data, it is completely off brand. There's all kinds of reasons why SMEs would say, no, this is a horrible answer, even if it seems technically accurate. So that's kind of one of the primary reasons we fine tune these models is, sometimes you might have heard us refer to this as enterprise alignment. But we're trying to tune the model to behave in a way that is compliant with the business, no differently than employees are trained to behave so that they're compliant with the business, right? All of us work for somebody. I'm sure we all get onboarded and we go through training and we have handbooks and guidelines and policies. Our models need to also be aware of these things. And then the last one is just pure efficiency. Those models, the bigger they are, the more expensive they are to run, sometimes exponentially more expensive. More often than not, if you're focused on a specific task, you could probably capture the knowledge from those big models and infuse it into a much smaller model, right? It's less expensive. It's going to be much faster. And I like this from Predibase. If you haven't seen it, the link's here in the slides. Do check it out or Google it. But I think this is kind of a nice example of the results, right? So the smart folks here, they went and fine-tuned a number of models. And you can see the performance on these tasks out of the box versus fine-tuned. And probably what's notable, you see GPT-4, and 3.5 Turbo kind of in the bottom half there. And certainly all of these other open models out of the box are not going to operate at that level. But if you need them to do great at a single task, once you fine-tune them, they are superior to it, right? They're actually going to be better than your bigger closed models. So there's a lot of value in fine-tuning these open models. Fine-tuning methods, there's a number of them. I just picked three for us to get started today. SFT is probably the classic approach. Generally speaking, you want to have SMEs, kind of generate some perfect responses for you, right? You want to have really great prompt response pairs, fairly simple, but it is kind of entirely dependent on those SMEs. So you could have some bias. DPO, direct preference optimization, is a simpler approach. We can kind of, there's two here, preferred and dispreferred, but it could be ranked, right? But the idea is we not only want to show, the LLM what makes a good response, but what makes a bad response, can help teach it and help it learn better. And then the last one, kind of reinforcement learning from human payback, is kind of more complex, right? There's certainly more steps and more work involved, although it does mean that you have more opportunity for kind of control and customization. But really, this one hinges on your ability to build a reward model, right? And then those foundation models can use that reward model to score their responses and continue to improve them until they can get better scores. So the handful of fine-tuning methods available to you. And I won't spend too much time on here. There are emerging methods as well that I think is worth considering. KTO and Orpal. We've used Orpal ourselves in our research space and with some of our customers. So there are always new methods available to you, and I think it's worth exploring those different methods. But like I said, these are just here for reference. So we know kind of where and why we want to optimize our Gen AI system, right, or our RAG pipeline. But in order to do that, you're going to need some training data, and that's certainly where Snorkel Flow is going to come into play. We think about trading data and really more than just trading data, just about everything involved in kind of, optimizing, influencing, managing, controlling, evaluating. All those things typically come down to having labeled data in some way, shape, or form. And that includes the training data. So for embedding models, we're generally looking for prompts and chunks is really what you want. So I mentioned at the beginning, if you have chunks, you can use an LLM to generate synthetic prompts for you. That's a helpful way to get started. There are other variations, right? You could have a prompt, a chunk, and a label. And the label is just really telling you whether this is a relevant or an irrelevant example. Or you can do a prompt, chunk, right? Prompt, good chunk, plus bad chunk. Sometimes I might say triplet in these examples. But one thing I want to mention here is that please remember to have a strong desire to hunt down for those bad examples. So we call them hard negatives. These are examples where the context looks like it should be a good match for the prompt, right? So you have some information. This looks like if I was answering the question, I'd probably want it, but it's not, right? And you typically need an SME to help you identify those examples. Those ones are extremely valuable, right? Those are the areas where the embedding model is going to get tripped up, where it's going to come up short. So don't just find, perfect matches to teach your embedding model. Find some really bad examples and some really tricky bad examples. And those can have a really big impact. And of course, diversity and balance, right? Depending on the task, depending on the types of prompts, try to make sure that you can match your training data to align well with your expectations on how users are going to be interacting with it. And again, on the process side, fairly simple, right? Get some SMEs to help you with ground truth. You can use an LLM to generate some synthetic data. And then that last step, which I'll touch on in a moment, is trying to capture SME domain knowledge that can help you improve the quality. So again, manually create those chunks with SMEs. It's good for ground truth. It's good for evaluation. Use a really powerful, or very good LLM to help you generate synthetic pairs, can be helpful. And then within Snorkel Flow, we can capture SME domain knowledge, right? So these are the things that they intrinsically judge or look for when they're reviewing stuff. And so if we can understand what they're looking for, we can take that off their plate by doing it for them. And then finally, little note here, depending on the structure of your training data, that will also impact the loss function that you use. These loss functions are how models teach themselves or learn to get better in that fine-tuning process. So here for reference. And then finally, fine tuning the LLMs a little bit more here than I would say the embedding model, right? A little bit more to consider. Our perspective is that it's more of a life cycle, and probably this should be a standout for most people, is start with evaluation, right? At least understand what you're working with. If the model and the retrieval are working great, then move to production, right? I mean, if you're hitting your accuracy levels, that's fantastic. More likely than not, that's not going to happen on your first effort. But once you've done that evaluation, it can help you understand where you do need to improve the model, right? Create the training data, help support that, fine tune the model, and then start again, right? Do another evaluation. These evaluations, what an important aspect of them is in the far left column there, you'll see these slices. And so what we try to do, and I'll show you an example in a minute, is we try to categorize the prompts that we're going to be feeding to our Gen AI system, because that can help us find where we need improvements, right? It's not enough to know that your model is 80% accurate. What does that mean? Is that other 20% end of business, bankruptcy, catastrophic scenarios? Are those 20% trivial and not, that impactful? Where is it, right? Is there just a particular type of question that's tripping up your model? So you need, more granularity to help identify where the model is coming up short, and then you can build the training data to help, resolve that challenge. And so for us, we do this with this notion of slicing functions. So kind of given a training data, prompts and responses maybe you've captured from your model, we slice that up. And then we can kind of look at that response by accuracy. Like I said, very insightful. And then in terms of, getting to that training data, it starts with SMEs to give us some ground truth, right? We need something to begin working on. It doesn't have to be a lot. Then we have this notion of acceptance criteria. And this is what I mentioned earlier when I talk about the SMEs and their domain knowledge. If I were sending responses to an SMA team, and asking them to accept or reject those responses, certainly that's a pretty tedious task, depending on just how many they are. The alternative to that is to talk with those SMEs and find out, well, what are you using to judge these responses? We refer to these as their acceptance criteria. More often than not, we can capture those, right? There's some examples here, but other examples might be, does the response mention a competitor's name? That's a no-no for us, right? So please create, a heuristic that checks for competitors' names and ensures they're not in a response. It might be that we don't like responses that are too verbose, right? Anything over, 1,000 characters is too much, or we like things to be structured and bulleted. We don't ever like to say, I can't, or we can't, or we won't, right? There's all these things that SMEs use. So instead of having them, apply those things one at a time, over the course of hours, days, weeks, months, we capture that and then we apply it more broadly in the platform. And then the result of that is the quality model, right? We now have a way to judge whether responses are good or bad. And then from there, we can filter out the good ones, or good and bad, right? Depending on our approach, that we can use to create training data for those models I just talked about. So that's kind of the path of, we're starting out with almost nothing. A lot of people start out with nothing, right? We don't have something to fine tune our models just yet. So some ground truth, SME domain knowledge applied at scale gives us a quality model, filter out the training data that can be most effective. That is where my story ends, though, right? So Snorkel Flow is here to help you get to that point of getting, high quality training data. We need somewhere else where that training data can actually be put to work. And so that's why I'm going to hand it off to Colin, who can show us how AWS comes into this equation here.
Thanks, Shane. That's a really great overview of all of the different kinds of data creation and fine-tuning tasks that are necessary to really optimize a generative AI application. And so when we think about that, like you see here, the sort of the very tip of the iceberg, where the generative AI application is represented in this lovely metaphor. If we jump to the next slide, we see the actual scope of work that's underneath it. And this is everything from S3 and the decisions your company makes about what kinds of data are safe to work with. All of our database analytics and data lake offerings, whether it's Parquet files in S3 that are made accessible through distributed SQL with Athena, or it's EMR jobs that are crunching unstructured data into parts that you can make use of, or even something like an AWS batch running across volume of images that are in S3 and doing the OCR. All of that technology lives inside of our product suite in analytics, machine learning, and data. And we have a whole complement of things there available for you that work well with Snorkel and can help you with the complexity of building these kinds of applications. When you're building a generative AI application, we know that those models in the marketplace are super useful in a generic sense. If you want to ask a large language model for general information, that's going to do really well for you. But ultimately, when it comes to making money and succeeding as a business with these technologies, it's your data and your ability to bring that data to the model, whether it's through retrieval augmented generation, classification and recommendation, or interactive conversational experiences, or even fine-tuning your own models for your own tasks. It's your data that is really the differentiator for how you use technology. And for us, the things that unlock your data with this technology is what we refer to as our generative AI stack. Today, we're going to focus on these bottom two layers. We're going to talk a little bit more detail about Amazon Bedrock, and then we're going to talk a little bit more detail about SageMaker. What you should take away from this is that we really do have offerings for you. If you're building the largest foundation models in the world, we have hardware and technology available in our Silicon, in our NVIDIA family of instances, our Ultra clusters and cluster high-performance compute offerings at the very bottom layer of the stack. We have a great suite of tools that are available to you through SageMaker for your own machine learning development. And then we have the Amazon Bedrock offering, which is a pay-as-you-go multi-tenant software service that gives you access to amazingly powerful models in a bunch of domains. So the thing to understand about Bedrock, again, token-based pricing, pay-as-you-go, REST-based API on top of a choice of leading foundation models. So there's a large number of models available in the Bedrock family. In addition to those models being available, there are model customization options. This starts with retrieval augmented generation and a product called Knowledge Bases for Bedrock, and it makes it really easy to configure your own retrieval augmented generation against your data. It includes an agents framework that helps you build autonomous data and language processes on top of these foundation models in your own data. And it really emphasizes security, privacy, and safety. So these are the models available to you in Bedrock from some of the best frontier model laboratories in the world. We have AI21 Labs and Amazon family models there that have specific interesting architectures from AI21 Labs. We have our own models that are curated and built upon data. Amazon has selected and includes embeddings models, it includes multimodal embedding models, it includes an image generator and a family of text generative models that can help you in a variety of RAG scenarios. We have the market-leading Claude 3.5 from Anthropic in terms of benchmark performance. Claude 3.5 is sort of at the top of that leaderboard. Very large model, extremely capable, and available conveniently with per token pricing. We've got models from my hometown, Toronto, Cohere, with their command, as well as their multilingual embedding models. We've got a set of open source models from Meta. They're really relevant to this fine-tuning discussion, both on the using the models to generate your fine-tuning data, as well as being great bases upon which to fine-tune. Similarly, Mistral has a set of open models that are accessible for fine-tuning, as well as large text generative models. And then at the end here, we have some of the best image generated models in the world for Stability AI. Something to keep in mind when working with Bedrock, we will never enrich, enhance, or train the underlying models on your usage data or your data. Okay, we do have fine-tuned training options available in Bedrock that will allow you to train a custom version of these models. to be deployed into your account and available for your account's use only. But we do not have the ability to take your data and enrich the base model outside of your account. So your usage is safe, your data is safe. It's never going to contribute to the performance of the model. All data is always encrypted, so it never lands in an unencrypted format, and it's always transferred through your virtual private cloud. It remains in the region in which the API is processed. So if you have data locality sensitivity, if you're working in regulated industries, we meet those needs by making sure we deploy these models in the jurisdictions where you need that data locality or data residency, and they're eligible for all of the highest compliance restrictions, including healthcare applications in Europe, plus all of the standard compliance that we look for in enterprise class systems. Okay, so that's Bedrock. If your style of working with these models is a little more in-depth, a little more hands-on, Amazon SageMaker is a suite of tools that are all API-backed, that are composable. You can choose which parts of SageMaker to use. You don't have to use it all. You can complement it with tools like Snorkel. And it enables you to build machine learning and foundation models from scratch, to customize existing foundation models quickly and easily, to launch inference, to do experimentation measurement, to do model drift detection, to do dark launch and A/B testing of models in your environment. All of this is easily available to you through API, and it has access to a ton of foundation models through a partnership with Hugging Face, a ton of interesting embedding models, as well as connections with labs like Cohere, like Meta, so that their models are available for you to fine-tune on a paper instance basis inside SageMaker. Okay, that's the SageMaker product. I think we're going to jump to the demo now. Thank you.
Okay, so this is going to be a pretty quick demo. What I really want to do is just set up kind of a challenge that some of your teams might be facing that you can sort of connect with, and then sort of walk through a fine-tuning workflow using Snorkel and some AWS tools. So today, I'm going to just pretend that I'm working at a company called Shield Healthcare, and I'm building a co-pilot over health insurance policy documents. So these retrieve benefit detail plans and compare the benefits of those plans. So I have a small application here that's going to sort of act as like the ground state. And what I'll do is I'll show you, some questions, and then we'll kind of just evaluate really briefly, if I ask it a question like compare the medical deductible between two plans, I'm going to get a response. But if I'm not an expert, I'm not going to know exactly, what the accuracy of the numbers in that response are. And what I'll do is I'll show you, some other queries here and say like, okay, how does marital status change eligibility and coverage? And this might highlight, another potential error mode in your current Copilot system where, the response may be really long, or it may contain sort of formal or informal sort of language or phrases that aren't really aligned with your enterprise. And so what we want to do is be able to evaluate this. And what we'll do is we'll sort of try to fix these through a fine-tuning process. And so what I'll do is I have this enrich tab here. And what we can do is ask it the same question and say, like, after fine tuning, we can see like we'll get a much better formatted response that doesn't contain any sort of informalities. And so how did I go sort of, from this baseline to this nicely formatted response is sort of through this fine tuning process. And this will act kind of as our guiding light through the demo. So we'll see here, I have a baseline llama model, and I'm going to develop a data set on Snorkel Flow that takes questions and responses from our current baseline model and then identifies which are good responses and which aren't good responses for that kind of like formality metric. And then we'll fine tune our model on that. And then we'll ask it the same questions again and evaluate those new responses. So the question that, I kind of want to pose here is like, how do we actually develop this data set to get these reliable labels for acceptable responses? And so the workflow today is we'll ingest, a set of QA pairs onto Snorkel Flow, and then we'll develop that quality model on Snorkel Flow that labels these QA pairs as accept or reject. We'll fine tune our baseline model with this labeled data set, and then we'll evaluate our fine tuned model. going through this process at a high level, I would take, the QA pairs from my current state. And what I'll do is I'll just show a really quick ingestion of some subset of that data using AWS. So, I start here in my like S3 bucket, and all I'm going to do is just take my like Snorkel public data set that I have here around my healthcare iteration data set. And I'll come over to the Snorkel platform. This is where I would upload data sets. Just going to quickly click the upload data set button and give it a name. And then you'll see I have cloud storage capability here, and it just asks for my S3 file path. So we've set up that in the background with all the sort of credentials you might need for your AWS system. And then I can just select a training set here, and it's going to verify this, sort of pull it in from that S3 URI. And I can give it, it's going to actually look at that data set, give me some feedback on it. And then I'll say like, oh, okay, generate some new UIDs for me, add that data source, and this is going to get ingested onto Snorkel Flow. This will act as our starting point. So let's just preview that. And then we'll say, okay, look, I have a bunch of question and responses from the current iteration of my Copilot. And now I want to evaluate those. And so the way that I'll go and evaluate those is I've created over here a set of label schema to do that. And I can do that in a sort of more fine-grained nature rather than just a simple accept, reject. We can also look at like completeness, correctness, and tone for those responses. And so if I had, an annotation team, what I can do is create batches for that annotation team. And I'd go through and I'd say, okay, based on the actual content of these responses, have the team annotate, okay, does this have a polite tone, accept, reject? Is it correct? And is it complete? And then overall, if I reject any of these, maybe I also reject it as a response and I don't, consider that a good response for one of these particular reasons. And so what we can do then is, your team might go ahead and evaluate some of these. I'll come back to my overview, and then I'll say, okay, if I look at my overall response acceptance rate, what I can see is, I'm only sitting at around 45%. And so what we want to do now is say, okay, let's take some action to kind of improve that. And what we'll do is we'll develop this data set with a quality model on Snorkel Flow. I also have an evaluation pane here where I can look at it from what we call at Snorkel different slices to say, subsets of data may have different accuracy metrics for the same acceptance rate. And so this is that ground truth acceptance rate from my annotation team. And then what I can see is, they're all hovering around 45%. And so, okay, how do I take action to actually improve that? That's this quality model development process. And so what I'm going to do is I've imported this set of 3,000 question response pairs. And now instead of individually annotating each one, what I'm going to do is write a set of labeling functions that will accept or reject them based on that content, combine the signal of those labeling functions into a quality model, and then iterate on that quality model to get these reliable labels. So I'll come to my studio page here. And so now, I had my sort of SME subject matter expert hat on doing the annotations. Now I have my data scientist hat on to develop this quality model. And for the interest of time, because we want to really focus on just the fine tuning aspect here, I've already gone ahead and developed, a high accuracy quality model. And so I can just give you sort of some context for what the labeling functions might look like. So for example, there's a really simple pattern matching function. If any of the responses contain one of these informal words, then reject it. I also have the ability to include some prompting here. So for example, I've, just set up a prompt to query ChatGPT, GPT-4 to say like, does the response contain informal words? As an example, we could also use a SageMaker model to do this. And then we also have embeddings where you take your like sort of embedding space, do some clustering, and then identify, from those clusters what good labeling functions might be. And then what I want to show here is, I can iterate sort of toward a production quality model. And then this model is just a simple classification model. And it creates, from there, we have these training sets that have the labels. And so what I want to do now is take one of these training sets and do my fine tuning process on this training set that I've got from my quality model. So develop that quality model. We're now going to come back to this sort of fine tuning area and say, okay, let me find my quality model. Okay, I have my quality model. It acts as my expert labeler. this is going to come and label my training set. And so what I'll do now is kick off a fine-tuning job where we started with this baseline Llama model, and we're going to now do create a fine-tuning model. So I'll come over to a notebook here, and you'll see I have this notebook tab. This is all still in the Snorkel Flow platform. So we have the ability to write all these queries right in our Python notebook. And so I've already set up kind of all of my credentials in the background here. And so what we'll see is I have this get quality data set. And so this is just going to get my training set from here. So I have model 4. I also have training set 4. And so this is going to get that training set. And then I just have a threshold to say, get all the responses that were accepted. And then that will create my fine-tuning data set. So I run that, and then it says okay, it found 554 responses for that fine-tuning data set. And then I'll come over here, and now I can actually, use my initial baseline model here and then kick off a fine-tuning job with it. And so you'll see I've already done that, and it takes, a few minutes. So I might just kick off that job and just sort of show what it would look like. And then we'll sort of just, kind of baking show style, see what the impact was. So I just kicked off this fine-tuning job. If I come over to my training jobs here, what I can do is refresh and then see, okay, yeah, so we actually have one in progress that I just kicked off, and I was doing some earlier. So you can see that we've kicked off this fine-tuning job, and probably in about 12 minutes, it will be done, and then I can now access that fine-tuned model. And so what would I do with that? So now that I have that fine-tuned model, I'm going to give it the same set of questions that I gave the baseline model, and then have it generate a new set of responses. And then now I can evaluate those new set of responses. So I have some code to do that down here, but while this is running, so we're just going to kind of quickly go through and say, okay, we've done our sort of, quality data set, kicked off our fine-tuning job. Now we'll come back to our evaluation pane. We'll assume that we've done the fine-tuning. We'll assume that we've generated the new responses. And now typically what we have to do is say okay, we have those new responses. We may have to ask our annotation team to go ahead and look and evaluate what those new responses are. However, we now have the quality model. So this gives us essentially a free evaluation. We can come to our evaluation pane, and I can say, okay, let's compare the two models. And I'll click on my fine-tuned llama. And so I'll see here my acceptance rate for ground truth. I don't have any data for my fine-tuned model. That's because I didn't ask any SMEs to go and evaluate that. But my quality model does this automatically. And so it essentially makes a prediction for what the accept reject criteria are. And we can see that those new responses are much more aligned. I can also view this just on a small plot here, and we can view that as a slice metric and say okay, that, how successful was our fine-tuning process? Well, in just that one stage, we were able to go from, this 48% acceptance rate to just over 90% acceptance rate. And then additionally, if I want to gut check that, I can come back to my app here, and I already kind of did that initially where I looked at this enriched model. This is that fine-tuned model, and we see, the response has bullet points. It doesn't use any informal language, and it's much better than my initial response where it's using that informal language and is kind of a long drawn-out response. Hopefully this gives you some idea, about how you might run this process using Snorkel and AWS together.
When you first got started, you had a number of QA pairs that were loaded. So the question was, were these created by experts, or where did we come up with these?
Yeah, so you can imagine that you might have a production copilot, and you could take a subset of those, and then you might ask yourself, well, if I have hundreds of thousands of questions, how do I decide which set to evaluate? And so there are many different methods you could take for that evaluation. You could do some unsupervised learning and clustering to get specific questions around, or get a wide swath of questions, so they're very different. For demo purposes, we just had generated a bunch of questions and based around different heuristics that we were looking for. But you can also imagine that these would be from your actual customers or your customer service agents.
Gotcha. Another one that I think kind of hinges on this a little bit in the eval process, do you provide experts in the loop? And I might rephrase that to what are the role of humans and how do we think about humans in the loop?
Yeah. So, maybe specifically what we could do is take a, well, I mean, I'll go back to my like eval page, right? And so what we can see is, as an example, this acceptance rate ground truth, this was provided by experts, right? So that would be like from your expert team or a set of domain experts that had some indication on like what a good or bad response was. Over here on the quality model side, what we want to do is essentially circumvent the amount of time needed to do that manual annotation. And so that quality model, right, captures a lot of the information or the heuristics that those experts might use and is now able to make predictions on any amount of data. So if I went back to my quality model here, right, this is like, okay, reject responses that are really long, accept responses that contain a particular phrase, are clustered around something, contain particular words. So that just gives you an idea, right? Like that's kind of like the ethos behind the quality model, is it captures that domain expertise.
Got it. This next one I could probably help with, does Snorkel fine-tune embedding models or text generation models? In this case, it seems like you fine-tune the text generation model. So the short answer is both, and the follow-up is yes. So in our demo here, we showed creating some training data and fine-tuning the foundation model. But absolutely, the training data that you curate, whether it's for the embedding or the LLM, it usually just comes down to the nature of the training data, right? Prompt and context versus prompt and response, and ultimately where you're setting out to. I think, Colin had mentioned it earlier when we were looking at that slide. There's all kinds of embedding models and foundation models to choose from. So in our world, it doesn't make a difference which one it is, right? Embedding or LLM, pick something that's available to you, curate the proper training data, and we can go to work on it. How does the fine-tuning, this demo, fit into general fine-tuning strategies like quantizing and distilling? That's a great question.
Yeah, so right in this case, I think as Shane mentioned, our focus was around fine-tuning the embedding models such that we could identify, how to fix these generation errors. In terms of quantizing, distilling, what we might say is, I developed an actual distilled model to do the labeling piece. And maybe I'm not, particularly sure exactly what the strategies you're posing are in terms of like, this is just one example, and I'm sure that there are other examples and ways of fine tuning, right?
Yeah. I think the 2 cents I would add to that. Oh, sorry, Colin, you have something?
Yeah, if I were to add to that, the thing I would say is that you think about fine tuning orthogonally to something like quantization or distillation. Distillation is taking an existing model, including its fully tuned state, and teaching a smaller model to have the same distribution on fewer parameters. So you're not really teaching it anything new. You're kind of compressing it. Similarly, quantization takes a different style of compression where it changes the precision of the weights. It makes the weights less precise, but in doing so, makes the model smaller, but tries not to lose any of its accuracy. So all those techniques, quantization and distillation, they don't depend on curating training data. They depend on having an existing model well suited to task, and then doing a series of transformations on it, or a teacher student kind of training for another model to make it smaller. Okay, it's not like tailoring a model to a task. It's just a kind of compression.
Let's see here. I'm going to kind of take a quick through. So this might be a good one, I think, for both of you. Other than customer service, what are some use cases where you see companies applying LLMs, let's say Gen AI, a little more broadly in the context of banking, perhaps, or finance?
Yeah, maybe I can pose one, and then if Colin has another example. So maybe, one example that we've seen is like information extraction. So you can imagine information extraction from financial services documents. So, if a financial services company or bank wants to get information from like, let's say 10K reports, there are thousands of those out there, they might try to utilize Gen AI infrastructure to be able to pull out interest rates or values from those. And so we've seen that to be pretty common.
Yeah, if I think about underwriting scenarios in general, there's always a set of pricing factors that need to be discovered from trailing documents. And these models can be super helpful in getting sort of those underwriting factors out of the trailing documents quickly, whether it's for like retail or commercial lending or insurance. If you think about investment management, portfolio analysis, being able to look at a basket of instruments and grab all of the unstructured data in the universe that you have access to about those instruments and summarizing it really effectively to get to either a structured information product or a report that can help you understand what a portfolio or a basket of instruments looks like really, really quickly. So those are just a couple of examples from a couple of different domains.
And there's also an interesting one that you guys might both have, some insight and perspective on. The question, I think, is really how much training data is needed. So in this particular case, Q&A pairs, let's say for fine-tuning an LLM, what are we looking at here? Hundreds, thousands, many thousands? How should we approach this?
Yeah, maybe I can start and then Colin, you can chime in. So, in this case, right, we were just looking at a reasonably small subset, about 3,000 QA pairs. And so what I would say is on that is, depending on how I got those QA pairs or generated them, they may or may not cover all the possible questions that a customer or customer service agent may ask. And so what we would do is just go through this iterative process. Our accuracy metrics that we're showing are based on that subset of data. And so if, we start to get at other queries or other questions that fall kind of outside that distribution, we may want to resample and collect more data. And so that's kind of why we sort of look at this as an iterative process where it's not always a clear answer as to how much data is needed. It depends on each problem, right?
Yeah, I want to echo Chris is absolutely right. Like when you think about your system for this, think about creating a channel with your customers to collect the data and to have the right processes to curate that data once it's collected. What you're interested in is capturing the diversity of the usage and a balance of the usage. That means you don't need like the same question 16 times. You're not really interested in frequency, but you're interested in examples that are unique and diverse that cover the breadth of your usage scenario. And it may be really difficult to anticipate that because of how high dimensional language is. And so having a good channel with your end user, either through your application or through some back-end process on your data, can help you identify those examples quickly. And Snorkel is a great tool to help with that.
And then I think we'll try to get two in here real quick. The first one I'm going to touch on, just because I saw a couple of folks here circling around it who had missed the beginning, and there was a question around evaluation metrics as it's related to, say, hardware performance, or lack of a better word. So in our world, in Snorkel Flow, our evaluation is focused solely on the quality of the responses that are being generated. There's certainly different tools out there if you're looking to measure throughput or latency or other dimensions, which maybe, Colin, you might be familiar with some, but they're outside our wheelhouse, right? We have a strong focus on data quality and response quality. And then kind of to follow up on that with some questions about, we also just touched on it a moment ago. And so I'd say that the only overlap is where Colin and Chris were just a second ago on the distillation, that, generally we look at this through the lens of data quality and response quality. But yes, one of the benefits of fine tuning when you get into distillation is certainly the efficiency of it, right? If I can take the capabilities of Meta's 405B model, which would be quite expensive to run 24/7 for a long period of time. But if I could take what's important from that and squeeze that into, say, a 7B model or a 13B model, it's going to be just as good, but certainly much more efficient. And for us at Snorkel, we're only looking at it through the perspective of how can you transfer that knowledge from one to the other. So like I said, you're probably going to want to look at other tools if your concerns are around, throughput, latency, something like that. So outside my wheelhouse, Colin, I don't know if you have anything to add on that one.
The thing that I will say is, so transformers are computationally quadratic, and they're actually they're very expensive to run, is what that translates to. So that expense shows up in the capacity you need, in the latency, and then in the number of parallel requests that can be handled. That latency sort of puts pressure against that. So small models are well, small, I should say smaller, because they're not really like, they're still talking 7, 13, 20 billion parameters. These models are way more efficient than like the 100 billion parameter model, but you're sacrificing generalization and range, right? You're getting more specific capability, you're getting more specific performance around a more limited range of tasks, and you're giving up the generalization or the large generalist nature of the model when you make that size trade. For lots and lots and lots of context, that's a really wise size trade because you're getting, better latency, lower costs, but it means that the model is not going to be as generally capable. So like Shane points out, sometimes you can use a large model like a Meta 405B, right, the Llama 405B, to do generating of training data and to help you get a really great corpora that you can then fine tune a 7 or 13 billion parameter on that really, really exceeds your needs, but doesn't do coding, won't write you a poem. It won't do those things, but it will meet your needs for your task.
Awesome. So to everyone attending, thank you for joining us. I know we still have some questions that we didn't get to, so we're going to do our best to connect with you offline. Colin, I just want to personally thank you for joining us today. We appreciate your time. I know you're a busy man. Thank you very much. Chris, thank you for the demo. That was fantastic.
Thanks, Shane. Thanks, Colin. Appreciate it.
So hopefully we'll get to see both of you again in the near future here. And for everyone that did join us, thank you for joining us, and we'll see you next time.